So, in connection as well to equations of functions, because we will be really dealing with equations of functions for most of the time in our subject, do take note that before this video, we've been always writing our equation as y equals x squared, and something like that. Now, for functions, we have to explicitly show that our x goes to our rule, and then it will be our y. Now, most of the time, and you have seen this before, that instead of using this, we use something else to show that the rule, usually symbolized by letter f for function, is the one that is being used to manipulate x to get y. So instead of y, we will have f of x equals something. And this is what we call the function notation, where y is our output, f is the name of the function, and x is the input. This means that if we're going to use a mapping, there we go, that x is the specific element in our domain, f is the rule. This is the one that we are using, such as multiply to 15. This can be your multiply to 15, multiply to 15, multiply to 10, multiply to 10, then subtract 2, and so on. And y is our output. Say, for example, we have y equals 2x. This, we all know that this equation represents that for every x in our domain, we will have to multiply to 2 to get to our y. And to show that this is in fact a function, we shall say that the function f, which is this one here, if we input, if you remember in the previous videos, we use x as an input. If we input x to f, what will come out is x multiplied to 2. That's why we have this one. And as we all know, the output is y, which is very similar when you input your x to the function machine. That's why we say y equals f of x, meaning saying that y equals 2x and f of x equals 2x is the same. This is read as, let me place it here, f of x, not f times x. This is f of x, and more often than not, we will interchange our equations for our functions, like y is equal to x squared plus 1, and I will also write f of x is equal to x squared plus 1. And that is the function notation.